The views and opinions expressed on this program are those of the producers and the individuals appearing on this program, and do not necessarily reflect the views and opinions of the staff of the Sun Prairie Media Center, its members or underwriters, the board members of the Media Center Commission, Charter Communications, TDS Telecom, or the staff and elected officials of the City of Sun Prairie.
Hello, this is John Quinlan. Welcome to Forward Forum, recording this on July 11, 2019, 9 days out from July 20th, 2019, which will be the 50th anniversary of the Apollo 11 landing on the moon. And we're very pleased to have in studio special guest, Ed Churchwell is with us. Ed is a professor emeritus of astronomy at the UW-Madison. Former chair of that department, is that right?
Yeah.
Mm-hmm. And someone who continues in retirement to do public speaking, works with the UW Space Place, and talks about issues related to our exploration of space, but also specific topics such as the formation of stars, infrared and radio astronomy, the formation and structure of galaxies, a whole variety of subjects, including the study of extraterrestrial life. So we hope throughout the hour both to emphasize the importance of this upcoming anniversary and also how it relates to a broader range of issues and humankind's presence in the universe, what this means. Great deal to talk about. Ed, hey, welcome to Forward Forum.
Thank you very much, John.
Well, let me start at a basic place. We're gonna show a couple of clips in just a minute that evoke those historic moments on the moon. But one of the things I often ask my guests is, what got you into this line of work? What attracted you to issues of astronomy and space, if I may ask?
Well, to me, I had a wonderful teacher in college who turned me on to astronomy, and I knew, after the first week of that class, what I wanted to do. But before that time, I had no idea about astronomy and no concept that I would ever be interested in doing something like that. But once it grabs you by the throat and never let go.
I think I've told you this story, but my life may have taken a different path. When I landed at UW in 1978, my goal was to be an astronomy major. It's a complicated story. I think I was really in love with math. I was the son of a minister who was trained as an engineer, who was an expert accountant who could have gotten me through anything, and the grandson of one of the senior engineers at Western Electric, who clearly math wasn't a burden for him either. But somehow it skipped my generation. But what I was fascinated with throughout my time growing up, I was born in 1959, 2 years after Sputnik went up. And I was a fairly precocious kid. And I remember things going back to age 2 or 3. I remember the Mercury, Gemini, and Apollo missions. And long after Apollo 11 had landed, I was still watching through Apollo 17, not to mention the Soyuz rendezvous, the Skylab, the shuttle series. I've always been fascinated. And in some ways, some people look at this as a contradiction because my activism is in social justice related work, and they wonder, how could we possibly have invested all of these billions of dollars in space exploration when we had pressing problems here on Earth? I don't see that as a contradiction. Do you?
No, not really. I mean, NASA, when it was established, particularly when the Kennedy said we're going to try to get to the moon by the end of the decade, and that was in early.
We'll be showing that clip in a moment. Yeah.
And basically, because of that, NASA got huge amounts of money to do this, but it was, I think, basically. A lot of people did worry about this whole issue of how much money was going to space, and we had all kinds of social problems at that time.
And it was juxtaposed, of course, with our involvement in Vietnam at the time.
Exactly. The Vietnam War was going on. We were having all kinds of racial demonstrations and issues, and so it was really a tough time. But I think the space program actually lifted the country up in a way that probably wouldn't have been possible otherwise. And so I think it did a lot more good than the amount of money that we spent on the project.
And for those of our viewers who aren't students of history, I mean, 1968 was probably the most divisive year
absolutely.
in the history of our country, with the King and the RFK assassinations, the racial strife, the other things. In many ways, on July 20th, 1969, we came together as a nation, as a world, in ways that we'd never come together before.
I mean, even after the landing, these astronauts went around the world to cities and visited people, because the whole world was watching this. I mean, it wasn't just the United States; it was a worldwide watched phenomenon.
And the other event I think that brought us together was in Christmas Eve of 1968, Apollo 8, one of the early missions that didn't land on the moon, but the command service modules orbited the moon, and the image of a crescent Earth, tiny quarter size that you could blot out with your thumb, as the astronauts read from Genesis. In that moment, we were one Earth. We were just, it was amazing to see the tininess of our existence, and yet the importance of our existence in the greater universe.
That's still my favorite picture from all those missions. Seeing the Earth you saw the surface of the moon and the crescent Earth down there, and we realized, probably better than any other way you could have done it, that we are just a little speck in the universe.
But I think Sagan and contemporaries like deGrasse Tyson and others have impressed on us this dichotomy. Yes, we're tiny in the greater scope of the universe, and yet we are this marvelous oasis that has a distinctiveness about it that we need to treasure.
There's a good probability that we're fairly unique in the galaxy in many ways.
And as someone who studies extraterrestrial life, I want to pick up on those themes as we move further through the interview. The other thing, as you evoke that image of the barren moon with the oasis of the blue Earth above it, is sometimes we think of it as a barren moon, as a lifeless world, as a place in some ways without significance. But the moon itself is really significant to Earth's place in the universe. First of all, it's a pair. It's a double planet in ways that nothing else in our solar system is like. But secondly, if there had not been a moon, had there not been the tidal forces, had there not been a moon that we pine to, for our poems of love and all kinds of other things, the presence of a moon in our lives is really significant beyond just a pale, lifeless world.
Oh yeah, absolutely. But it also has physical implications as well. I mean, the moon is the largest, most massive body relative to the mass of the planet that it's orbiting, of all the other planets, all the other moons in the solar system. And the effect of that, there's a gravitational, what if you call it, steadying effect, if you wish, that keeps the Earth from changing its axis of tilt to the orbital
So
plane.
the seasons and all kinds of other implications.
Well, yeah, over long terms, what that has done is it's caused the Earth to have a fairly constant climate. Okay, we haven't changed, the moon, the orientation of the spin axis of the Earth has not changed very much, all that much. It does precess a little bit on a 20-something thousand year orbit, but basically it has allowed the Earth to have a fairly constant climate for billions of years.
And is also allow a 24-hour day as opposed to, say, Venus and Mercury, which have days that are roughly synced to their orbits around the sun?
Well, I mean, the moon is, the rotation rate of the moon, of course, is synced to the Earth, so that it keeps always the same face toward the Earth.
The far side of the moon is a misnomer in some ways, because it really, it's the side that's always facing away from Earth.
Yeah, it's always facing away from the Earth. But the fact that it's so massive has a major impact on maintaining this more or less constant.
And I think
climate.
whatever observation I was making about the 24-hour day, of course, Mars also has a roughly 24-hour day, so that's not.
Yeah.
But Mars, by contrast, has two tiny moons, Phobos and Deimos.
Yeah.
It would be a very different world had it had something analogous
It
to
would
a
have.
moon.
Mars is a tiny planet, though. It's only a tenth the mass of the Earth,
Right.
and so it's not much different than the mass of our moon, and so as a consequence, this large mass has played a big role in the dynamics of the Earth, and in fact, the distance between the Earth and the Moon is slowly changing. There is a
few inches.
Yeah, it's very slow, but it is over a long period of time. The length of the day has changed on the Earth due to this as well, and it has complicated it.
That's why that laser
mathematically.
reflector that Apollo 11 put up there, that we can measure very precisely the distance.
Yeah, and that reflector, in fact, has played a big role in the basically the theory of relativity. Because it's you can measure precisely the separation between the Moon and the Earth, and that has implications for gravitational attractions and so forth.
There are so many different directions we could go.
Orbital interactions.
Absolutely.
Yeah.
Well, so in terms of placing it side by side with other moons in the universe, it's I think it's slightly smaller than, say, Ganymede or the other Galilean moons.
Yeah, but relative.
Triton.
But relative to the Earth, it's a very large satellite. Yeah.
But it's up there. I mean, it's within the range of the larger moons of the universe. So significant in that sense.
Well, the Moon has posed
a
number of interesting problems for the Earth because of this uniqueness of its mass relative to the Earth, and one of them is that the composition of the Moon, we now know from the Apollo missions, is very similar to the Earth. There's very little difference, and this has implications for where this Moon came from.
Now, what I saw last night was a documentary that posited that there was a Mars-like planet named Theia that crashed into the Earth, and then the material from the surface of the Earth eventually coalesced as the Moon. Is that
there was a huge, must have been a very large collision of an object about as massive as Mars, the best theory at the moment, and that collision basically released a huge amount of material from both the Moon and the Earth's crust, and ultimately slowly condensed, and a lot of that mass came back to the Earth, and a lot of it came to the Moon. And so you have a Moon and the Earth that have essentially the same composition because the surface of the Earth was more or less rebuilt from.
But if we're trying to trace back geologic realities of Earth from 4 billion years ago, the atmosphere, the water has limited our ability to do that. Essentially, the Moon is the way it was 4 billion years ago.
That's right. It's basically unchanged, and the fact that it doesn't have an atmosphere and has essentially no magnetic field means that the Moon has been bombarded by this wind from the Sun. The Sun has this very high-speed particle wind that has been bombarding the Earth and the Moon and the rest of the solar system for 4.5 billion years. And the surface of the Moon gets all of that. It's not. There's no way that it can protect itself. The Earth does. Most of those particles get, burned up in the atmosphere. Rarely gets any to the Earth. There's about 100 tons of material that lands on the Earth every day.
Now, are there opportunities for you as a radio astronomer were we to establish a radio antenna on the far side of the Moon that aren't available here because of the rush of radioactive of radio waves that come out of humankind?
Yeah, one of the great things would be to put a large or several large radio antennae on the back side of the Moon, because it's then protected from all the radio noise that we have from the Earth, and it would be an ideal place to do radio astronomy from. So a lot of radio astronomers would be very, very happy to have a satellite there.
I can think of 1,000 other questions off of this, but I think maybe what we'll do now is just move into these two short documentary pieces about the moon landing, and then we'll have a chance to expand on some of these other subjects in just a bit here. But Mara, if we could, let's roll that first clip, if we could. This is essentially a piece that CBS News, I think, produced on the 40th anniversary of the moon landing, and it's told very much through the lens of Walter Cronkite, who was the anchor. And we were sharing earlier this week excerpts from his biography. In many ways, Walter Cronkite, I think, was the guide who took us through this experience. He was especially enamored by the power of what was happening, a poet in many ways. Yes. Although Wally Schirra, his co-anchor astronaut, was joking that he would say something really profound, and we'll reflect on what he actually said when the moon landing occurred in just a second. But here we go with Walter Cronkite and kind of the journey beginning with Kennedy's speech and how that took us on the arc that led us to the moon.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the earth.
Good morning. Man is about to launch himself on a trip to the moon from this Florida launch complex. Astronauts Armstrong, Collins, and Aldrin sitting there atop the great Saturn rocket in their command module. My palms are sweaty.
You're now a member of the mission launch team.
6, 5, 4, 3, 2, 1, 0. Liftoff. We have a liftoff.
What a moment. Man on the way to the moon. It seemed that the whole world stopped as man set out on the adventure to escape from his own planet and to set foot on a distant one.
Hello there, Earthling. Hello there. 11, Houston, if that's not the Earth, we're in trouble.
The lunar module cutting itself free from the command module, beginning the maneuvers which should place it on the surface of the moon.
Roger, Eagle, contact. Roger, how does it look? The Eagle has wings. Houston, you're a go for landing, over. Roger, understand, go for landing. 30 feet, 2.5 down. We're drifting to the right a little. 30 seconds.
Oh, jeez.
Tranquility Base here. The Eagle has landed.
We're home.
Man on the moon.
Boy.
Okay, we're going to be busy for a minute.
There he is. There's a foot coming down the step.
I'm at the foot of the ladder.
Armstrong is on the moon. Neil Armstrong, 38-year-old American, standing on the surface of the moon on this July 20th, 1969.
That's one small step for man, one giant leap for mankind.
Well, for thousands of years now, it's been man's dream to walk on the moon. Right now, after seeing it happen, knowing that it happened, it still seems like a dream.
Go ahead, Mr. President. This is Houston out.
Hello, Neil and Buzz. This certainly has to be the most historic telephone call ever made from the White House.
Thank you, Mr. President. Honor for us to be able to participate here today. We think that you've done a magnificent job up there today. Over. Thank you very much. It's been a long day.
Man has landed there, and man has taken his first steps there. I wonder just what there is to add to that.
Wow, what memories that brings back.
Yeah.
You know, just to punctuate it, yeah, so Walter Cronkite, his highly anticipated words as the moon landing occurs were, oh boy.
Oh boy, yes, right.
But what else are you going to say about something like this? So just my reflections on the day that this occurred, I was just 4 months short of 10 years old. I was at my grandparents' home in suburban Chicago, my granddad being one of the senior engineers at Western Electric. He'd helped develop the transistor and all kinds of telephone technology. He was the perfect person to be in the room with, because I could ask him any question and he would have an answer for it. My father was a minister at the time, but had also been trained as an engineer, and so it was a great place to be. But I remember in terms of the launch of the Saturn V, we were vacationing at Jellystone Park up in Door County. And I knocked on the camp manager's door at 6 in the morning asking to see the TVs, and he wasn't going to let me in until 9 a.m. and I was so frustrated. No. But I was a geek. I was watching all these shows, and I continued long past, I think, the mainstream public interest to Apollo 17, which is all the way through. But where were you, and what do you remember of that night?
Well, I just defended my PhD thesis, and we were packing to get ready to go to Germany. I had a postdoc there, and but I was glued to the television, through the whole mission.
Yeah.
I mean, it was for me, in a way, an almost a life-changing experience because it made my enthusiasm for astronomy even greater. The drive to explore. In my case, it was more exploring ideas of what makes the universe tick and so forth. But I think it changed the whole human existence in a way because as I say, this was everybody around the world was watching this. It wasn't just the United States.
Billions of people.
Yeah.
An audience had never focused on a singular event. The entire world's attention.
Yeah, and so the whole world was watching this, and so.
I think of films like Hidden Figures that developed, in this case, 3 African American women who were master mathematicians. But I would imagine that was a redeeming, affirming, moment for her to understand how mathematics had been instrumental to getting us to where we were.
Yeah. I think a lot of people who, of course, didn't get the publicity and so forth stood behind all of these missions. I mean, the orbital mechanics that was involved, in a time when our computers, in those days, was still kind of primitive.
Well, there's a scene in Apollo 13 where Jim Lovell is watching the second stage being loaded onto the vehicle assembly chamber. He's remarking, yes, and we live in a day when a computer making millions of calculations can fit within a single room. The same computer that would fit in the palm of your hand or in a chip now. But
yeah, exactly. I mean, the computers were pretty primitive, even in 1969 for sure.
And thinking back to Apollo 13, many of the calculations that were occurring were real human beings were verifying them. When Apollo 13 was facing a crisis and other things. Well, let me go on to our second clip just so we can get these out of the way, and then we can move into a more detailed discussion and some other things. This clip is more told from the perspective of Neil Armstrong, the first person on the moon. It's from an ABC News retrospective that was done in the 40th anniversary 10 years ago. David Muro is the narrator. I believe that's the case. And but you get more of a sense of the personal story, and we'll talk about this in just a moment. But one of the things that wasn't captured in that last clip is actually the moment of landing on the moon was actually much more dramatic and much more potentially dangerous than what's depicted, and we'll pick up on that theme in just a moment. David Muir describing Neil Armstrong's journey.
It's one small step for man, one giant leap for mankind.
Almost 250,000 miles away, the moon came much closer that summer night because of Neil Armstrong's famous first step. Not quite 39 years old, on that July evening, Armstrong spent 2 hours, 21 minutes walking in the lunar dust, taking pictures of his crewmate, Buzz Aldrin, raising the American flag, and stretching America's imagination. So many parents watching with their children.
Dear men from the planet Earth, first set foot upon the moon. It came in peace for all mankind.
With Americans divided at the time over the Vietnam War, the moon landing, at least for one night, brought a beleaguered country together. It was an American goal met.
We choose to go to the moon in this decade and do the other things, because that challenge is one that we're willing to accept, one we are unwilling to postpone, and one we intend to win.
It turns out it was sheer happenstance that made Armstrong the first man on the moon. NASA's Apollo crews worked in rotation, and Armstrong's crew was assigned to Apollo 11. He was a quiet, reserved man born in small-town Ohio, fascinated with flying from his teens. He joined the Navy after college, flying dozens of combat missions during the Korean War. He then flew experimental planes for NASA, becoming an astronaut in 1962. Before Apollo 11, he had been in space once in 1966 as commander with co-pilot David Scott. The mission was cut short when a broken thruster sent them tumbling out of control. That moonwalk by Armstrong and Aldrin was the most watched television broadcast in history up to that point. 1 out of every 6 people on Earth were watching. Later we learned Armstrong thought that landing on the moon, not walking on it, was far more challenging.
4 forward, drift into the right a little.
Shooting over the lunar surface, looking for a smooth place to touch down, Mission Control had warned him he had less than 30 seconds of fuel remaining when they finally made it.
Houston, Tranquility Base here. The Eagle has landed.
It was a singular moment for this country, national pride soaring when they came home, greeted by crowds across America and in 29 other countries. After that, Armstrong tried to return to a private life, teaching at the University of Cincinnati, serving on corporate boards, living on a farm in Ohio, and making rare speeches to urge that exploration go on.
There are great ideas undiscovered, breakthroughs available to those who can remove one of truth's protective layers. There are places to go beyond belief.
Neil Armstrong had said he did not want solely to be an icon, but he could never escape his place in history and where he made history, on the moon.
Of course, a special aspect of the story of the moon landing was it wasn't an unmanned flight. It did involve real human beings. Mara, if you could bring up the 2 beginning slides of the 3 astronauts. Neil Armstrong among them, of course, he most famous of all on the left because of his role in being the first person to step on the moon. Michael Collins, back up one more, I'm sorry, Michael Collins in the middle there. He was actually the commander of the command module, the command service module, which orbited, he waited things out. He was the loneliest person in the universe for a time as he was on the far side of the moon. And then Buzz Aldrin, who was, I think, the second in command, also someone who stepped on the moon. I believe that both Michael Collins and Buzz Aldrin are still alive. I know I've heard Buzz speak recently. Neil perhaps passing away about a decade or so ago. But we alluded to this, but as I mentioned in the clip, you wouldn't have caught this watching on TV, but those final minutes, couple of minutes, were really very, very precarious ones for Neil. Could you elaborate on what was going on as he was making that final ascent?
Well, I mean, the original place they had chosen to land, it turned out as they got closer, Armstrong realized that there was a boulder field there, and if they had landed, they probably would have not been able to get back off the moon. And so they kept going, and as he pointed out there, they were running low on fuel, and so they only had about 30 seconds of fuel left when they finally landed, but they had to move further away to find a smoother place to land. And the other problem is that nobody had any idea of how thick the dust layer was on the moon.
Just could have sunk right into it.
They could have sunk right in. We had no idea. We knew that there was a dust layer, the moon was covered with dust, but the thickness was still a question.
And it turned out it was a
only,
couple of inches thick.
Yeah, a couple of centimeters or so. It wasn't all that much, but the moon had been basically bombarded by the solar wind for 4.5 billion years, and all that dust was produced mostly by high-speed particles from the sun.
Well, we're talking about the personal aspects of this. You were telling me a story a few moments ago of Harrison Schmitt, who was the last person to walk the moon. Geologist, but someone who came and spoke at the UW.
Well, he actually was
an
associate professor actually for a while. So we taught a course together. It's a group of, I think, somebody from the economics department, geology, and engineering had a joint course on the resources of space, and the engineers were interested in this because of these little glass particles that make up the dust in the sun or on the moon is loaded with helium-3, and helium-3 is a a key element in the way that the sun makes energy, and so that there's a lot of energy there. If you make helium-3 combine with helium-3 again, it produces a lot of energy. And so that was one of the motivating factors for this course, was to look at the helium-3. And in fact, one of the professors in the engineering department had gotten a lot of countries interested in all this dust on the moon because of the fact that they were so rich in helium-3.
So this could lead to the ability to use fusion technology.
Yeah,
for
that's
example.
right. That's right. And that of course has never been realized because it takes a lot. We still don't know how to deal with it.
To contain that somehow
To
too.
contain,
the
to
temperatures.
actually produce energy, from like the sun does, because you need high pressure, some way to contain it, and we still haven't figured out entirely how to do that yet.
So I would imagine the other thing he was interested in is that composition of the moon dust, which proved to be problematic because it's a silicate that is tiny little particles that are razor sharp. So it was getting into everything.
Cleans to everything, yes.
Yeah, but as a geologist, I'm sure he was fascinated by the geology of the moon.
Yeah.
As you were pointing out earlier, here was a place that was essentially frozen in time in terms of evidence, not only what the moon was like 4 billion years ago, but also the Earth.
Yeah, the moon also has a lot of thorium, and thorium is an interesting resource for because of the fact that you can use thorium now for basically just a decay of thorium, which would produce nuclear energy as well. And we now have thorium reactors, here that a lot of countries are doing experimental work on with, and it's a safe source of nuclear energy, and there's lots of it. And the moon has a lot of thorium as well, and so there's reasons for a lot of countries to be interested in the resources that the moon might provide.
And we'll talk about this in the context of Apollo 11, but with each mission, it was Apollo 12, Apollo 13, of course, that had to abort the mission because of the explosion, then 14, 15, 16, and 17. With each place, in some ways, things became more advanced. These were more treacherous landscapes, or at least more diversity. The geography of the moon, or the geology of the moon, became more complex with each mission.
Yeah. Yeah, but we learn more, of course.
Right.
And I think it's almost 400 kilograms of moon rocks and dust and so forth has been returned to the Earth, and we've learned a lot from analyzing the moon rocks here, and particularly as it relates to the origin of the Earth, or of the moon and the Earth, and so. There was a lot of scientific return from these missions, but what fascinates me is the fact that this occurred. All of the people who actually stepped on the moon was on a very short period, from 1969 to 1972.
Only 12 of them.
Yeah, only 12, and nobody's touched. No human being has touched the moon in almost 50 years, and we thought, at the time when Neil Armstrong first stepped on the moon, that this was the first step of human exploration of the solar system, and that there are likely to be colonies on the surface of Mars by now, and colonies on the moon. And of course, that's not happened.
Although it looks like we're on the verge, perhaps, of returning to the moon, both the U.S., China, other places.
And so it's probably will happen at some point that we have a colony on the moon, but the moon is, as I say, is kind of a dangerous place. I mean, Neil Armstrong's footprint on the moon probably may not recognize it today because it's being bombarded by solar wind particles.
Because I think the perception at the time was it would be that way for tens of thousands
well,
of
it'd be
years.
interesting to see. I'd like to see a picture of it now, because there are little micrometeorites that also.
Right.
The moon has no protection like the Earth has a lot of protection because of our atmosphere, very thick atmosphere. And so, as I say, like 100 tons of material falls on the Earth every day, but we're not aware of that.
Well, they say that I think we're perhaps 80 hours out in their spacesuits, but they're very fortuitous that a micrometeoroid or something didn't come tearing through their suits, even though they had some modicum of protection.
Yeah. But so if you have a colony on the moon, you have to find some way to protect it from these micrometeorites and other larger.
If you had a geodesic dome, it would have to be impervious to.
Yeah, either that or they'd be under surface or something.
Right.
If it's a long-term kind of endeavor, the likelihood of being struck by micrometeorites is pretty large.
And they're envisioning the same thing, I think, for Mars, that many of the
Mars
structures would probably have to be subterranean.
Yeah, Mars has it has an atmosphere, but it's a very thin atmosphere, and so you'd have to be protected.
Well, I want to explore that more, the philosophical aspects of that question of why we didn't immediately go back to the moon and why it's taken so long to be thinking about Mars and other destinations. Also juxtaposing that with the unmanned exploration that has been very promising. But before we do that, let's just go through some of the pictures of Apollo 11, if we could. We've seen the two astronauts. I think the one we left off on was this picture of the three bounding into into the Saturn V, about to take off in their great adventure, and the launch of the Saturn V. Again, amazing. I had a 6 foot tall model of Saturn V when I was 10. I don't still have it, but I was just fascinated by what each stage did. The first stage boosting you into the lower atmosphere, the second stage getting you almost into Earth orbit, the third into Earth orbit, and then eventually leading you to the moon, and then turning around and getting the LEM out. And then, I knew what each of those different component parts did. I was a pretty precocious kid.
John, I think you have a lot of Walter Cronkite.
I do. I think I channel my inner Walter Cronkite, and he's my hero as a journalist too. So let's see what we got here. We've got a picture of the LEM, and this is something that Neil must have taken from the surface of Buzz Aldrin coming down.
Yeah.
The LEM itself, Mara, if you can go back one for a second, they talked about this in Apollo 13, which is in some ways one of the best pictures, I think, even though Ron Howard is faulted with making a few leaps of logic and stuff like that. But I mean, it was essentially just two pieces of tinfoil thick. It was a spacecraft, so it didn't have to have a lot of substance to it, but not a lot between you and the vacuum of space. And yet it was exactly what people needed to get down there. And then on to the next, if you could. And so here's a picture of Buzz almost all the way to the surface.
Yeah, now a lot of people at the time, you see that big backpack that they have, how it just looks huge. And they say, well, how could they carry all of that weight? But of course, their weights are very small because the gravity of the moon is much less than the Earth's.
Right.
And so they were bouncing around, and it was easy to do because there's the weight was much lower.
If it had been on Earth, I think it was something like 400 or 500 pounds, but when it's 1/6 the weight, that's what it is. And next slide, please. So you mentioned this, but it is fascinating. Just all aspects of that first footprint and what it meant. As you said, we knew in that moment that indeed we didn't have feet of dust.
Yeah.
But also, again, I think there was this mistaken perception that somehow this would stay here forever. But
well,
maybe
it
not.
might. I mean, it's not clear how many. These the micrometeorites and so forth that they're hitting. The solar wind is being bombarded all the time, but a couple of micrometeorites close to that, could destroy.
Sure.
It. So it would be interesting to see a picture of it today.
Yeah, it would be interesting to what are the ethical considerations about going back to that site? Should it be preserved as it is forever, or can we put new footprints into the sand? I don't know. Next slide, please. So this is this kind of iconic photo. Among other things, it was on the cover of Life magazine, and because the visor was reflective, you can actually see.
Yeah, you can see the person taking the picture, yes.
Exactly. But also the monochromatic nature of the surface, although I think there was color in some variation that you could see in other contexts. But the fact that there wasn't an atmosphere meant that the shadows were in stark relief and other aspects that made it a very different, very alien world. I mean, in many ways, I think what was described as a place that was prone to optical illusions if you tried to think of what you saw as analogous to what you'd see on Earth.
Yeah, that's right. It's a very different environment.
And next slide, please. So this is from a distance. Again, looking back, I don't know if that's Buzz or Neil. It's the photographer or the subject. But so this first mission, in some ways, it was to get there. But they were able to do some very interesting experiments. We talked earlier about the laser reflective array they were able to put up that could measure precisely the distance. But you have a sense of some of the experiments might have been?
Yeah, and I think this one in the foreground is probably the seismometer. I'm not sure, but that's probably the seismometer.
I know on a later mission, they actually, after the ascent module of the LEM rendezvous, they crashed it back into the moon, so the seismic waves could be measured, and they got all kinds of things. And this was active, I think, for quite a while into the future.
Yeah, and they of course the reflector. I don't know. The McDonnell Observatory had this laser that they could go shine every night on the moon, and that was a very good test of general relativity to measure so precisely the distance between the Earth and the Moon and the slight changes over time.
So the fact that the clock on Earth was not the same as the clock on the Moon, essentially, or?
Well, it's that, but it's also a test of gravity.
Okay.
Of gravitational interactions and predictions that you can make, from general relativity or special relativity.
So our evolving understanding is gravity as a force that curves space.
Right, curves space-time, and so that was I think one of the big returns on that particular experiment.
Which is very elegant in its simplicity. It's essentially you're shining a laser and you're measuring very precisely how long it takes to traverse the space back and forth.
Exactly. So you can test if you know the distance, which you do, you can determine that very precisely. Then you can also determine the speed of light and all kinds of good things like that. So so it was quite a nice return on the.
And UW played a role in maximizing that to a certain extent, or?
Well, I'm not. That's a good question. I'm not sure that. I don't think UW was involved.
I think you told me off camera before we started. I'm not sure if we got this into this discussion, but just generally, UW-Madison had a special role. The Space Sciences Center was constructed with funds that came out of this program.
That's correct. Yeah, that is correct. And of course, the UW put up the OAO2, so-called Orbiting Astronomical Observatory, and I think that was the first remotely controlled observatory in space or in orbit from space. First successful one.
I came out as a gay man in 1986. My first boyfriend, who was 13 years old, worked in that building, and
did he? Yeah.
And he also studied climate on Mars and all kinds of fascinating things. He was the perfect first boyfriend for me to have because I just loved touring that and visiting him up there and everything.
Yeah.
But we were making an analogy, just as Joe Elder, who's been a frequent guest in this chair, and the South Asian Studies Department has had a special role in terms of the federal government. The astronomy and space-related programs at the UW-Madison have always had that same kind of special role.
Yeah, well, as I say, Art Code, who was at the time the chair of the astronomy department, became the first director of the Space Science Institute in Baltimore. And he was teaching full-time at the time, so he would fly to Baltimore, to Washington, D.C. or Baltimore, and then when it was in the days when he gave lectures, he'd fly back. So he basically had a book of plane tickets going back and forth. And he did that, I think, for about a year or so.
And then Jim Lovell, who's from Milwaukee, was a Gemini pilot, and Apollo 8, and then on the ill-fated Apollo 13 mission. So he had Wisconsin roots too.
Yeah, right. Yeah, and there's others. Well, we had one of the persons who's on the astronomy faculty, Ken Nortzik, was also going to be one of the mission instrument specialists on, I think it was, I'm not sure if it was Apollo 13, but it was a mission, the Apollo 13, in other words, in any case, screwed up. his chances to go into space. He never got into went
I think
into
we were
space, but-
envisioning originally, it ended with Apollo 17, but originally it was going to go through Apollo 21 or something too. So
Yeah.
the two
So
factors.
they're all cut short.
Yeah.
As I say, to me, it's still amazing that only 50 years later, only 12 people have ever walked on the moon.
So we
and
will
in a
pick up
very
on
short
that.
time
Let's
frame.
just finish with a few more
Oh,
of the
it's
photos
okay,
first.
yeah.
No, that's all right. What do we got next, Mara? So so there are a lot of conspiracy theories, and one of them is, how could that flag possibly be waving on an airless moon? The answer is very simple. There were little wires in there that made it look like it was, but the notion that this all took place in a TV studio or all the other things,
Yeah.
maybe it's just the skepticism of the times we live in, but it's just ridiculous.
Yeah.
There is pretty firm empirical evidence that we went to the moon, right?
Oh yes, yes. Well, one question I've always had, after they landed on the moon, there's almost over 4 hours space before they actually came out on the moon. They were supposed to have slept at that time, but I can't imagine them sleeping during that period.
Well, the longer Cronkite footage says that, in fact, because they didn't sleep, then they moved the moonwalk up, which meant that it occurred more or less in prime time. Otherwise, it would have been in the wee hours of the morning. I mean, we all would have stayed up and watched it.
Yeah.
But I think there were a lot of reasons why, they were, understandably, the adrenaline was flowing. You got to get out there and get out there and do it.
Yeah, but they were constrained for over 4 hours in the lander.
That must have been horrible.
And, it must have been a terrible time. If I had had the chance to talk to Armstrong or Aldrin or any of the three of them, I would have asked, what did you do during that time? Did you actually sleep or not?
Well, this is just the standard story of the "Are we there yet?" kids. If 10-year-old me had been in there, I would not have let them stay in there for 4 hours. We would have gotten out and done something.
Yeah, right.
All right, next slide, if you could, please. And this is, I think, from the television camera that went up. The fascinating thing about reading about Walter Cronkite is I think he was a force for saying that it needed to be televised live.
Yeah.
Now, the initial camera was black and white. In some ways, I think it was done kind of on a shoestring. The shots of Armstrong coming down were in the shadows. People were having to use their imaginations a lot to what was actually happening. But when they moved the camera out further to see them bouncing around on the moon, I think there's a scene. Let's go ahead a little bit if we could.
Recovery.
Yeah, that's recovery. There was one of an astronaut bouncing up in the air, Mara. I don't know if it's out of sequence. Maybe it didn't get included. I think we're moving ahead. There was one where essentially the astronaut jumped up in the air and saluted the flag, about 3 feet up high. One thing to mention about this is we were concerned that potentially there were microbes or bacteria or other things on the surface of the moon that might come back and contaminate the Earth. And so the astronauts were very carefully quarantined, including taking refuge in essentially a large mobile home, and that's where the president came and spoke with them. But do you think that was ever, did we have reason to be concerned?
No, I don't think so. I mean, most of the scientists that I've talked to at that time also understood, that the moon, there's no easy way that there could ever be life on the moon because it's, there's no atmosphere. There's it's a very cold place. So I think most scientists thought this was an overreaction. But the NASA, it's probably good that NASA was concerned about this, because if we go to other places like Mars or whatever, that would.
Well, we want to be concerned in the reverse order. We don't want to take microbes or bacteria. Now, there was a sidelight in the Apollo 12 mission where they went and they visited a surveyor and unmanned craft, and I guess they discovered some bacteria that were left over, and they're trying to figure out had they survived somehow for a couple of years or what the significance is. But there's always that danger that we infect a world.
Yeah, the danger is greater, and going to either the moon or any other planet, that we infect it with our bacterial life forms.
But there are, I think, I can't remember if it's a probe to a nearby comet or something, but they're going to bring some rocks back into the Earth I mean, I suppose there is, in theory, some danger that there is some kind of an infection or something could be brought back. So they're still cognizant of that.
Yeah, there is the theory that life got started on the Earth basically by being hit by an asteroid or a comet or whatever.
Right.
And delivered first life forms here.
So I knew this was going to happen, but I think we're down to about our last 15 minutes or so. So I do want to explore some of those wider themes with you. We've talked a little bit just about where the arc of exploration went on the moon, but come back to that that central conundrum. So why didn't we go immediately onto colonizing the moon, onto exploring Mars? And where do we seem to be going now in terms of our further exploration of the solar system and the universe?
Yeah, I mean, I'm not sure that I know the answer to that, but one thing is quite clear that was a very expensive proposition to get to the moon. We were spending huge amounts of money, and I think it just became almost essentially untenable to continue at that level. So I think expense is one thing.
We live in an era too when it's essentially sometimes the public will is driven by what is essentially a massive reality show.
Right.
And so
exactly.
at the point where it became routine to go land on the moon, suddenly the political will wasn't there.
Yeah. After Apollo 17, people said, "Oh well, another mission to the moon." It wasn't anything like the Apollo 11.
Right.
And so I think we lost the excitement, of doing this. The general public, I think, did.
Well,
and
I'm understandably intrigued by our exploration of Mars, and I feel, of course, that's a natural direction we have to go. I think it's mitigated somewhat by the successful unmanned probes that have made their way into the universe. Most recently, all the surprises that came out of Neil deGrasse's demoted Pluto, which is a whole other subject.
Yeah.
But on the other hand, I do have some ambivalence about, for example, Elon Musk's professed motivation, in part that we should settle Mars as a bastion of Earth civilization in case we screw things up on this planet. Neil deGrasse Tyson spoke at the Nelson Institute Earth Day a few years ago, and in response to a question, he essentially said, if we can terraform Mars, why can't we re-terraform Earth? And I think that's kind of a central conundrum. I don't think the reason for doing it is so that a small number of us can somehow continue our civilization. I think there are lots of other reasons why we should explore. But what are what's your thinking about why exploring Mars would be important?
Well, I don't know about exploring Mars. I would say that we do have driven to ask the question: are we alone or not? Are there other life forms probably not life forms in the advanced life forms that we understand on the Earth within the solar system? I would be surprised if that were the case, but. The question of does advanced civilizations, life forms that we might be able to actually communicate with, that's a question I think that a lot of people are interested in. And it turns out that that's also a very difficult thing to do.
Let me put two possible exceptions to that, and it just depends on what we mean by advanced life. But the Jovian moon of Europa, and this idea was posited in Arthur C. Clarke's 2001, 2010, those works, that underneath its icy crust is potentially a warm ocean, where life could have taken form, and who knows how it evolved. And we're going to launch a probe that will actually drill down in and perhaps investigate that possibility.
No, I think that's I mean, there are several places in the solar system where life could potentially thrive, and Europa is one.
Titan being a methane-based life.
Yeah, and so, but those are environments that Europa might, you might imagine ocean life surviving there and not going on without worrying about what the rest of the universe is like.
Ed, I apologize. We're down to our last 5 or 6
Oh.
minutes. It truly did go faster, but what I want to give you a chance to expand upon, because of the scope of your thoughts, are why is it we haven't discovered intelligent life in other places, or yet definitive evidence on exoplanets or other places? And what do you think? How will that evolve over time?
Well, let me give you my perspective on this a little bit. The Earth has millions of different species of life forms, right? I mean, the Earth is teeming with life. There's almost no spot on the Earth that you can't find evidence for life, even at the poles. But out of all these millions of different life forms, only one has evolved to the point where we have the possibility and the technology to consider trying to communicate with an extraterrestrial civilization. So the probability of a life form evolving to the stage that we're in is pretty low, when you look at it from that perspective. Now, a lot of that doesn't mean that we don't have intelligent life forms. I mean, we know that there are life forms that are pretty intelligent on the Earth, but either due to their physical limitations,
like whales,
dolphins, and so forth. They're not concerned about, as far as we can tell, with communicating with.
Hitchhiker's Guide to the Galaxy believes otherwise in terms of the dolphins.
Yes, right. It could very well be. But they haven't developed technology to do it. And so when you start thinking about all the aspects of what it would require for an advanced civilization to occur, and then you start asking, okay, how many of those are there in our galaxy? And then you have to ask, how many of them are close enough to us that we have any possibility to communicate with? The probabilities get smaller and smaller and smaller. And it doesn't mean that that's not something worth going for, but there are a lot of considerations. There are astronomical, biological, and sociological questions that you need to kind of answer to get some idea of whether there's a reasonable probability.
The other thought that's always occurred to me is, our world civilization is roughly 10,000 years old. Yeah. And in the scope of the 13 billion year history of the universe, that's a pretty small sphere. So there may be advanced civilizations to whom we are mere ants, and that are advanced way beyond our ability to communicate or sense their presence.
Well, one other thing that I'd like to just point out is that we have been capable of interstellar communication for only about 100 years.
Right.
And that's a stretch already.
And that only goes 100 years out into the Milky Way galaxy that's 100,000 light years.
Out of 4.5 billion years, it's taken us 4.5 billion years to get to the stage where we have the possibility.
Yeah.
And so you have to, when you realize that, you have to exclude a whole lot of star systems that will never live that long.
We're just a last thought, though, but do you see us, perhaps within your lifetime or my lifetime, maybe making that breakthrough discovery of extraterrestrial life?
It would be interesting if we could do that in my lifetime. I would certainly be interested in that.
Yeah.
There are, I think about, there are about 4 star systems within 5 light years of the Earth, and within 15, there's about 15 or 20 stars that are within 15 or 20 light years of the Earth or the Sun. And so possibly, if we're lucky, one of those might have an advanced life form, but we don't know yet.
Ed Churchwell, thank you so much for joining us today.
My pleasure.
My fellow geek.
That's right.
Again, we're discussing the 50th anniversary coming up on July 20th of 2019 of Apollo 11 and all kinds of other wonderful themes. I'm going to conspire with my producer and with Ed in just a moment to see if we can maybe stretch for another 5 or 10 minutes of a web extra, finish up a couple thoughts. But please watch this show and our other shows at forwardforum.net. Thank you so much for joining us, and have a great week.